Hi friends, without the waste of time, let's start the video. State Gauss law of electrostatics. State Gauss law of electrostatics. First we have to write the statement of Gauss law, which we have already read. Derive Coulomb's law using Gauss law. We have to derive the Coulomb's law. You know Coulomb's law. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. q2 r square or f is equal to f by q. Okay, next, Gauss law. It states that the total electric flux through the closed surface is equal to 1 by epsilon 0 times the net charge enclosed by the surface, where epsilon 0 is the permittivity of vacuum or free space. We know that the total electric flux, that is phi, which is given phi is equal to q by epsilon 0, or the total electric flux is equal to 1 by epsilon 0 times the net charge contained by the surface. Here q is the charge of the surface and mathematical expression is this: phi, that is flux, is equal to q by epsilon 0. Next, then the statement of Coulomb's law. We know it states that magnitude of force of interaction between two charges. Easily you can write this. This is also very easy. So I will introduce a very easy statement to you. That is the force of attraction and repulsion. The force of attraction and repulsion between 2 point charge. 2 point charges. The force of attraction and repulsion between 2 point charges is equal to or is directly proportional to the product of the charges to the product of the charges, and is inversely proportional to the square of distance between them. Okay, this is written. It states that magnitude of force of interaction between two charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of mean distance between the charges, and act along the line of the two charges, which act along the line of same. Mathematically, f is equal to 1 by 4 pi epsilon 0 q1 q2 by r square, which we have already determined in the previous video. Next, derivation. What is the derivation? We have to determine Coulomb's law from Gauss law. So let us consider a spherical Gaussian surface. This is a spherical Gaussian surface. Okay, which enclose the charge. The total charge of the spherical surface is q. Now consider a elementary Gaussian surface. This is the elementary part, which is dark in color. That is the elementary part of the Gaussian surface, and this area vector is very small, that is ds vector. So electric flux passing through it is given by electric field intensity into area. We know phi is equal to flux is equal to electric field into area. So here electric field into area, that is ds vector. The area is very small, ds vector, which is given already. This is the equation 1. Next, now total electric flux is given by d phi is equal to integration of E into ds into cos theta. Here dot is present, so it becomes E ds cos theta. Theta is the angle between electric field and ds vector, area vector. E ds cos theta. Here the area is along the direction of electric field, so angle will be 0 degree. Area and direction of the area and direction of electric field are same, so angle will be 0 degree. That means integration of E ds cos 0, the value of cos 0 is equal to 1, cos 0 is equal to 1. So integration of E into ds, integration of ds. So here the area of the circle is pi r square. Area of the circle is 4 pi r square. Because of the total Gaussian surface area, total surface area becomes 4 pi r square. Where r is the radius of the circle. So integration of E into 4 r square, we get phi is equal to E into 4 pi r square. Where 4 pi square is equal to surface area of the Gaussian surface, r is the radius of the spherical surface. But according to Gauss law, we know for every sheet, every surface, phi becomes 1 by epsilon 0 times net charge content by the positive surface. So here 1 by epsilon 0 into q, equation 3. Now comparing equation 2 and 3. What is the equation 2? What is equation 2? This is equation 2 and this is equation 3. So by comparing equation 1 and 2 and 3, we get q by epsilon 0 is equal to E into 4 by epsilon 0. So we get E is equal to 1 by 4 by epsilon 0 into q by r square. We get E. Next, since electric field intensity at a point inside the electric field is force per unit test charge, since we know that electric field is equal to force per unit test charge, force per unit test charge. Now F is equal to EQ. So we get F is equal to 1 by 4 pi epsilon 0. From equation 4 we get E is equal to 1 by 4 pi epsilon 0 q by r square, and we multiply q0, so we get the force. This is the required Coulomb's force of Coulomb's law, Coulomb's force. So we can easily determine Coulomb's law by using the Gauss law. This is completed. If you like this video, then subscribe my channel to get more video and handwritten note also.